Hello all, welcome to my channel PSA Tech Classroom. On today's video lecture, I'm going to share with you the Chebyshev filter approximation method. In the previous video lectures, we have discussed about the Butterworth filter approximation method, and today we are going to discuss about the Chebyshev filter approximation method. Before going to start this video, I would like to confirm that I would like to inform you that these Butterworth approximation method and the Chebyshev approximation methods both are the approximation methods or the designing procedures for designing the analog filter, or you can say you are going to design the filter in the analog domain. And one more thing I want to confirm you that here in the designing of these two methods, you are going to have the transfer function in the analog domain, means in terms of the h of s. This is the point that the students has to remember for the examination purpose. Now here I'm going to teach you the designing steps for the Chebyshev filter approximation method, as like as the Butterworth filter approximation method. Here also we need to find out the order of the filter. And then next point is to rounding off to the filter to the next integer value. I told you in the previous classes itself why we need to round off to the next integer value. Next we have to round off to the next integer value to increase the order of the filter, though increasing of the order of the filter gives you the complexity, but it gives you the exact or sharp separation of the cutoff frequency of the passband frequencies and the stop band frequencies. That's why we are going for the increase of order of the filter. Next is you have to calculate the poles of the filter. For calculating the poles, we need to have the formula of sk. sk is equal to a cos pi k and jb into sin pi k, whereas in the case of Butterworth filter, the sk is equal to omega c into e power j pi k, but here it is sk is equal to a cos pi k plus j into b sin pi k. Here a and b are the two parameters which are going to decide the eclipse coordinates, because the poles of the Butterworth filter lying on the circle, but when it comes to the Chebyshev filter, the poles are lying in the eclipse. So to decide the coordinates or the ranges of the eclipse, we are going to use these two things, a and b. So but the value for the a is equal to omega p into mu power 1 by n minus mu power minus 1 by n by 2, where omega p is the passband frequency, and b is equal to omega p into mu power 1 by n plus mu power minus 1 by n whole divided by 2. Here the difference you have to identify is the formula is the same, only the sign is different. For a it is minus, for b it is plus, and mu is equal to epsilon power minus 1 plus under root of epsilon power minus 2 plus 1, where epsilon is equal to 10 power 0.1 alpha p minus 1. Okay, if you know a and b, you can calculate the sk are nothing but the poles. Next, in that a and b values we got, now we need to find out the formula for pi k. Pi k is equal to same as Butterworth filter, pi by 2 plus 2k minus 1 divided by 2n of pi, and the k value is rolling from 1 to the order n. 1 to order n. So after finding the poles and after finding the order, we have to decide the transfer function. The transfer function h of s is nothing but a numerator by denominator. First we will describe the denominator polynomial of the transfer function. The denominator is nothing but the formula for denominator is s into s minus 1 into s minus s2 into s minus s3 and so on. Once again I am repeating, s minus s1 into s minus s2 into s minus s3 and so on. Here s1, s2, s3 are the poles we have derived by using the above formula, and after that we have to define the or derive the numerator function. The numerator function n of s will be given by substituting s value is equal to 0 in the denominator equation, and here the order you have to see. If the order value is odd value, then you simply substitute s is equal to 0 in the denominator and leave it. And next, if the order value is n even, then substitute s is equal to 0 in the denominator equation and then divide the result by 1 plus epsilon square. So this is the procedure you have to remember for solving the Chebyshev filter designing methods. The first one, once again I am concluding you, the first one you have to calculate the order. Next you have to calculate the poles, and next you have to calculate the denominator function, and next you have to calculate the numerator function. And here the formula for order of the filter here is n equal to cos h inverse of under root 1 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1 whole divided by cos h inverse of omega s by omega p. N is equal to see the formula here, n is equal to cos h inverse of under root of 10 power 0.1 alpha s minus 1 divided by 10 power 0.1 alpha p minus 1 whole divided by cos h inverse of omega s by omega p. This formula is the same. The remembering this formula is very easy because we already practiced it for the Butterworth filter. In the Butterworth filter, at the place of log, we have at the place of cos h inverse we are using the log. So this formula and this entire part is same. So in the Butterworth filter, we are at this place we are using the log, and at this place we are using cos h inverse in case of the Chebyshev filter. This is the key point you have to remember. With this we have completed the Chebyshev filter designing steps.